All right. Hi, everybody. Thanks for coming out to NDC. Obviously, this time it's a virtual NDC, which is a little bit different. This is actually one of my favorite conferences. I love being in Oslo, seeing everybody. This time I'm not in Oslo, but I am seeing everybody, so that's nice. At least I'm really still happy that we were able to have this conference. I'm so thankful that you were able to join us. I hope that you've learned a lot over the last couple of days. If you had workshops, if you went to any sessions, I hope you've had a great event. And I hope that we'll actually be back together physically in real life next year. But in the meantime, we still get to have this event, so that's great. My name is Edward Thomson. Today, I want to talk about GitHub Actions, and in particular, how you can use GitHub Actions for continuous integration and continuous delivery within your applications. Real quick introduction. Again, my name is Edward Thomson. I'm a product manager at GitHub. Currently, I work on NPM. NPM is the package registry for JavaScript, but I moved over recently. Before that, I was a product manager on GitHub Actions, so I actually helped build what I'm going to show you today. Super excited about that. Before working on GitHub Actions, my background is actually in version control. So I've been building developer tools for many years. At GitHub, at Microsoft, at SourceGear. So I actually worked on Git and other version control technologies prior to working in the CI/CD space. So I've been really fortunate to have a career where I've been working with developers, building developer tools, and helping them ship their software to their customers. And so one of the things that I've been really privileged to be a part of is GitHub, because GitHub is really how people build software. Now, of course, not everybody hosts their code on GitHub or uses GitHub, but in 2020, no matter what you're building, you're using open source technologies. If you're building .NET, the entire .NET stack is open source. If you're building in C, that's also open source. And of course, we use components that are open sourced, and that almost exclusively means that they're built on GitHub and they're built collaboratively. And so fundamentally, GitHub is key to the software development experience. So you're using tools that have been developed on GitHub, even if you yourself aren't using GitHub. And so that's a real responsibility that we feel at GitHub to you, and really to the entire software development, the entire community. We have a responsibility to build tools that help you and all the other software in the world. We have a responsibility to help you build your software better. And the interesting thing about building software for other software developers is that we're a picky bunch. We want the software that we use to be the thing that we imagine in many cases. And at GitHub, we can only imagine so much, right? I work with a talented bunch of people, but we can only create so much for you. And at some point, you want to take over and extend our platform. And that's something that's really important to us to be able to allow, because again, we're developers, we understand that this is a thing that is important to you and that it's important to the ecosystem to allow. And so one of the things that we've always been proud of is the way that we allow you to extend our platform. So the first way that we did this was with what we call GitHub Apps. So we've had a piece of functionality called webhooks that we've built into the GitHub platform from the beginning. And a webhook is basically just something that will call your application when something on GitHub happens. For example, when somebody opens a pull request, you can register to have a webhook that is delivered every time somebody opens a pull request, or every time somebody comments on an issue. And so GitHub will just like open a TCP port to your whatever you specify and send you an HTTP payload with the issue comment that was delivered, right? And so from there, you can build automation around this. Every time somebody comments on an issue, you can actually perform an action and do something and send back a response. So you can authenticate to GitHub and you can do something. And by gluing these this technology around webhooks, you can extend the GitHub platform. You can basically assign a new issue to somebody as soon as somebody opens an issue in your project, right? You can look at maybe some details and assign it to a first responder, for example, so that it gets triaged. You can add labels to it and those sorts of things. And so you can start to automate tools around your repository and basically extend the GitHub platform to do what it is that you want to do. And that's very, very cool. This was our first attempt at allowing you to extend the platform, but it has a problem. And that problem is that you have to bring that computer along, right? This is not something that just happens for free. You need to provision a machine. You need to, whether that's in the cloud or even, inside your data center, something under your desk, you have to bring the machine along. And that means you're responsible for its maintenance and paying for it. And that's not ideal. That's actually not the way that we want you to have to extend our platform. We want to allow you to extend the platform, but we also want to allow you to do it in a cost-effective way. And so the idea behind GitHub Actions is that we take all that knowledge out of GitHub Apps and we host it for you. This was at least the original idea behind GitHub Actions. The idea is that we will bring the compute. So now, every time an event occurs inside your repository, instead of just firing a webhook, now you can configure something that runs within the GitHub Actions platform. And so you can now take that issue comment and perform a response. Now, we started GitHub Actions in beta almost 2 years ago, about a year and a half. And the way that we did this was that we gave you the ability to run Docker containers every time something happened in your repository. So every time an issue comment happened, we would run a Docker container that you specified. And that was really, really cool. It was really, really powerful because now you could take that custom logic that you would have put into a GitHub app previously and just Dockerize it. And now we'll run it for you inside our infrastructure. We'll take care of all of the execution and we'll pay for it. Now, this was great. We were really excited about this. We launched it as a beta and immediately our customers started doing really cool things like triaging issues every time a new issue was opened or issue was commented on, something like that. And they would start automating things around pull requests. And what we hadn't thought of, but it turned out our customers did, was the immediate thing that people started to do around automating pull requests was running a build and running tests. Now, this probably should have been obvious to us, but it wasn't. We weren't building a CI platform. We were building an extension on top of GitHub. But our customers, what they wanted to extend was CI. And so we hit pause for a second because we really hadn't built a CI platform. We hadn't built something that could really take care of most people's applications. If you had a simple Node app, we could run your tests in a Docker container, no problem. But if you were building a .NET app on Windows, if you were building an iOS app, you need to run an iOS app on Macintosh. That's part of Apple's license. You can only build it and run tests there. So we actually hit pause on our beta. We rethought GitHub Actions and we came back with something that kept the spirit of being able to extend the GitHub platform, but we allowed you to, instead of just running in a Docker container, we gave you real virtual machines in our cloud. So, so today, GitHub Actions allows you to extend the platform, but it also allows you to run CI. We've optimized GitHub Actions for CI and CD workflows. So we give you a real virtual machine. You can do whatever you want with it while it's running, and so you can run your builds that are a little bit more complicated and a little bit more CPU memory intensive than something that will just run inside a Docker container. Excuse me. And we've extended the platforms that we support. Now we support not just Linux, but we also support Windows. We have Windows virtual machines that you can run in, and we have Macs. And we had to go and actually get Macs and rack them inside a data center in order to support this. So this was a long time coming. So we were very happy with what we learned in our beta program, and so we pivoted quite a bit and introduced GitHub Actions that really supports continuous integration workflows across Linux, Mac, and Windows. And so we've had that for almost a year. This launched, I guess, November of last year. And that's really what I want to talk about today. So the GitHub Actions that you see today is repository automation that will respond to GitHub events. It provides CI/CD build and test functionality with Linux, Windows, and Mac runners in the cloud. So let's take a look. So this is a simple project that I have. This is a .NET application. You can see the .sln. You can click in and start to see that it's actually a Razor app. And one of the things that I might want to do is start to set up CI/CD workflows around this. And so what I want to do is just click on the Actions tab. Now, this is a tab that just showed up in your GitHub repository one day. And so that is the gateway into GitHub Actions. The first time you click that, if you haven't set up any GitHub Action workflows previously, the first time that you click into this, what you'll see is some simple ways to get started. So GitHub Actions, of course, like most CI systems, is something that you have to configure, but we want to make that easy for you. We've got some real simple ways to get started. So we've got, if you've got a Rust project, we've got a sample workflow that you can get started with to start building and testing your Rust application. Same for Ruby, same for Java. We've tried to give you a number of ways to get started very simply. And of course, what we try to do is detect the language that you are using. And we usually do a pretty good job. This is in fact the same mechanism. It's a tool called Linguist. If you've ever clicked into this bar on GitHub, what we do is we analyze every repository on GitHub to try to figure out what kind of application it is that you're building. In this case, we've identified that this is a C# application, which it is. And so we can take that information and suggest starter workflows for you for GitHub Actions. In this case, I've got a .NET Core application, so I'm going to click Set up this workflow, and I'm going to scroll down, and I'm just going to go ahead and commit this file, and that is actually going to kick off my first CI build. And so while that's running, let's actually talk about what this CI definition looks like. So the first thing that you'll notice is that this is YAML. Now, a lot of people don't love YAML. I'm actually quite a fan, but YAML gets a bad rap for a number of reasons, like it's a little bit dense as far as its syntax, and it does have significant white space. So white space is important. But one of the cool things about GitHub Actions is that we've actually got a nice editor here in GitHub. So we've actually got completion and syntax highlighting and suggestions. So I can actually take advantage of this, and I don't have to know everything about YAML myself. So that's how GitHub is helping you with the YAML. Okay, so fundamentally, YAML is the most common configuration language for DevOps workflows. So of course we adopted it as well. But if you don't like YAML, this editor is one of the things that you can use to help you. So just walking through the configuration. First of all, every workflow has a name. And so we've given this one, it's just .NET Core. That's the one that came out of the box, so we'll keep it. The next thing is that we have triggers. So this is what defines how and when rather, your workflow gets run. So in this case,
be straightforward. And then I have an I subject analyzer.
Looks like we got a little bleed through. Again, this is the triggers. So this particular workflow is going to run every time our branch is pushed to, and every time a pull request is opened. And we can actually define the branches that we want to run on. So in this case, we'll only run when the master branch is updated, whether that's through git push or merging a pull request. When something lands in the master branch, we'll run. It will run on pull requests. So we'll do pull request validation every time a new pull request is opened against the master branch. I actually don't use the name master for my main branch. I use the name main. So let's go ahead and update that. We'll commit that, and that'll kick off a new run. And while that second build is running, we'll actually let's keep talking through what this workflow looks like. So we can specify a number of jobs. Each job runs on a virtual machine. So we have exactly one, and so that's our build job. We've chosen the virtual machine that we want to run on. I'm running on Ubuntu latest. That's the label that we've chosen. So we're going to pick one of the Ubuntu virtual machines out of our pool. We'll run this workflow there. This could be Windows latest, for example, if we wanted to run on Windows. I like to use the place that I'm going to deploy as the place that I run my CI. I want to make sure that my build runs and my tests pass exactly like they would in my deployment environment. I deploy this particular app to Ubuntu, so I'm going to keep it as Ubuntu latest. But again, this could be Mac, Windows, or Linux. And then we go through the steps that make up our build and test. The first thing we do is check the code out. The next thing we do is set up .NET Core. This basically puts .NET Core, the .NET CLI in the path at a particular version. In this case, it's version 3.1.101. That is the version that we want to build on, test with. And then we're going to run .NET Restore. We're going to run .NET Build. And finally, .NET Test. So that's just a really simple, straightforward CI and pull request validation workflow. If I click over to Actions, I can see what happened. There we go. Click on Build, and in fact, my workflow ran. And so I can actually just click through and see exactly what happened. I can see that my tests ran and that sort of thing. So pretty simple, pretty straightforward to get started with. It's just one click. I can take the defaults. So that's very nice. I can extend that. And the next thing I want to do is look at a more complicated setup. And here I've got this seemingly simple application. It's modeled after a pocket calculator. If you grew up when I did, we didn't have iPhones in our pockets. We had little calculators, and they looked kind of like this. They were LCD, and you could do 2 + 2 = 4, 4 + 4 = 8, 8 + 8 = 16. So very straightforward. And I have a Node.js application that powers this. So this is an HTML and JavaScript front end on top of a Node.js backend, and that's right here in this repository. And this is, so I have a shameful secret, and that's that I grew up as a Java developer. I spent a number of years working as a Java developer, and so my applications are a little bit complex. And so this is actually on top of a service. So I've got an arithmetic service, and I can click in here and take a look at that. And so that front end that I talked about, that JavaScript and HTML front end, actually talks REST to do arithmetic. So this is really just 1 + 1 as a service. However, I do have some nice unit tests around this, and so I want to make sure that this code builds and tests pass every time I'm working with it. That's super important, right? I used to work with, as I was a Java developer, I used to work with a guy who would, write his code all day long, and when he was getting ready to leave for the day, he would just check it all in and get in his car and go. He didn't bother to do the build. He didn't bother to run tests. And so every day at the end of his day, like 4:30 p.m., our trunk would be broken. We couldn't build out of it, and we couldn't test it. And so that's when I understood the value of continuous integration builds, right? So now what we can do is we can set up gates so that we always have builds running before the code gets merged, so every time you open a pull request, and that we can make sure that the tests pass. And this is super important. This is, I hope, something that you're already doing, but I just want to underscore the importance of this. And so let me click through, and again, GitHub Actions suggests the type of workflow. It's figured out that I've got a Node.js application, which I do. And again, let me change the name of my branch to main. I'm going to go ahead and check this in. That will go ahead and start that build. There we go. And while that's building, I want to talk through exactly what this workflow does, because it's you'll see a lot of similarities to the last workflow. Again, we're running every time that there's a push or a new pull request open against main. We're going to run on Ubuntu latest, and we're going to run a number of steps, which is basically restoring our dependencies. We're running NPM CI to do that. We'll run NPM run build and then NPM test. But actually, there's a little bit of a difference here from the last time. And one of these, and this difference is that we've got what we call a matrix. This is actually my favorite part of GitHub Actions. I think it's super powerful and yet really, really simple. What a matrix allows you to do is specify just basically a key value pair, or a key and a set of values, and we will run these steps multiple times. We'll basically run it expanding that key for each of these values. So you can set up this really simple set of steps: NPM CI, NPM run build, NPM test. And what we will do with this matrix is that we will run each of these steps with the key expanded out to 10.x, then we'll run it again with the key expanded out to 12.x. So what we'll actually do is we will run 3 builds, one for node 10, one for node 12, one for node 14, and you haven't had to do any particular setup here. All you have to do is specify where you want those keys to be expanded. And so in that case, we'll run this action, just like we set up .NET in the previous example. Now we're going to set up node, and we're going to do it with the version specified in the matrix. So what I actually should see if I click into actions over here is that I had 3 builds running. Again, one with 10, one with 12, one with 14. So that is a really powerful way to increase your build footprint across multiple versions of Node very, very simply. Okay. And I can, in fact, expand this a little bit more, right? If I click into this, I can actually make this matrix even bigger. So instead of just thinking about node versions, I can also think about operating systems that I want to build on. And I want to build on, let's say I want to build on Linux, Mac, and Windows. Well, I can run on Ubuntu, macOS, and Windows. There we go. And so what this is going to do is now I'm going to have another key in this matrix that I can use. And I can use that in my runs on right here. And I'll use this funny double curly brace syntax. That's the expansion of variables within GitHub Actions. And I can say matrix.os. So now I will actually have 3 operating systems running: Ubuntu, macOS, and Windows. And on each of those operating systems, I'll get 3 node runs. So node 10, node 12, and node 14. So I actually get a multiplicative effect really, really easily just by changing like 2 lines of code. When I start that and click over into Actions, you can see that it expanded that out, and now I have 9 different runs. So I get a lot of clarity about the code that's being submitted, the code that's running, very easily. And the reason I think that this is so important is because I want to make sure that my projects are healthy. I want to make sure that my coworkers don't just check a bunch of code in and go home for the day when nothing works. And so just to give you a concrete example of this, let's go back into my API. We'll go into the controller, take a look at arithmetic controller. And now you can imagine that I'm a new contributor to this project. This is actually an open source project. And so this is something that people can come into and potentially send pull requests for. And now, if you're going through this, this is again the REST API that does the arithmetic. If you're going through this, you might get down to this operations, and this is what maps actual REST calls into the actual arithmetic. Again, I said it was 1 + 1 as a service. I wasn't really kidding. And so, if you look here, you'll notice that the divide call makes a lot of sense. That's a function that returns a divided by b. Straightforward. That's how you do division. No problem. Multiply, a times b. Subtract, a minus b. But add looks a little bit funny. Add doesn't return a plus b. It returns plus a plus b. What's going on there? Now, if I were new to a project, the first thing I might do is want to simplify this. And so I might say, well, instead of plus a plus b, let's make this match, right? That's how you do math, a plus b, right? I don't know what that other stuff was for. And then I'm going to come down here and open a pull request. Click propose changes. That'll commit to a new branch, and now I can create a pull request. And now, since our trigger for the action that we set up was both on push, meaning every time something lands in the main branch, and on pull request, meaning every time a pull request is open against the main branch, which is what we've done right here, we're going to kick off a pull request validation build. And if we scroll down, we can see that we actually kicked off 9 pull request validation builds, 1 for each leg in that matrix. And I expected to see those passing, right? That was good code, a plus b, right? Well, let's see what happens. Let's click in on one of these failures to understand what the problem is. If I expand out NPM Test, we can scroll down. We see a lot of, we saw a lot of check marks, which are good, but it turns out we've got some failures as well. And in fact, our addition test failed. We can't add 2 positive integers. And if you're familiar with NYC, the way that it reports test results is with pluses are the expected value. This is kind of like a get diff syntax. Pluses are the expected value, and minuses are the actual result. So we expected 42, and we got 2121. It turns out our unit test does 21 plus 21 and expects 42. So it instead got 2121. What we've done is concatenated those 2 numbers as strings instead of doing addition on them. Well, why have we done that? Well, if we actually go back and take a look, we had plus A plus B, and now we've got A plus B. It turns out the leading plus sign in JavaScript actually coerces a string into a number. So by removing that, we've treated A and B as strings. We've done string concatenation. That's no good. And so that's why fundamentally we do continuous integration and pull request validation. And so we were able to catch this problem before it actually got merged into our master branch. So very, very important, right? Just one more example, and that is a, this is yet another project. This one is actually an iOS application. And if I pull up Xcode, we can see that we've got unit tests. This is actually in Swift. And if I just click into that, there we go. We're going to go ahead and start it. What I've got is a concentration style game where you have two tiles, two matching tiles hidden within these, and you can turn over one tile, two tiles at a time to try to make a match. And one of the things that I want to do when I built this game, I wanted to make sure that you could in fact win the game. And like I said before, now I'm a product manager. I'm not a programmer anymore. So the best test I could come up with was just a brute force. So, hey, so I now have unit tests that make sure that you can in fact win the game. I want to make sure that this code builds and that the tests pass over here on in my CI. And so I can actually get started. If I click into Actions, it does in fact know that I've got an iOS workflow running Swift, and it gives me some nice defaults. I need something a little bit different though. I want to, and basically you can do CI just like the way that you run your application on the command line, right? And the way I actually run this app is using Xcode build with the test and specifying an iOS simulator. So I can do that right here. I'm gonna go ahead and start that commit. And while that action's running, again, I'll just walk through this. Just like before, I've got my triggers up top. So I'm going to run on push and on pull request. I haven't specified branch limitations here, so they will actually run on every push to every branch in my repository and every pull request that gets opened. And then we're going to run on macOS. Again, Apple actually limits your ability to run to build their applications and to run the iOS simulator to actual physical Mac devices. And you can virtualize those Macs, and we've done that, but it actually must be Mac hardware. And so you actually have to run it on a Mac. And so that's what we're doing here. We'll, again, check out the code. We'll run the checkout action, and then we'll run just like we would on the command line. This is exactly how I build my project locally. Let's go build test, and we'll give it the project, give it a scheme that's telling us that we want to run the tests, and finally specifying an iPhone simulator at a particular version. So with that, if I click into my actions, we can see exactly what it's doing. And this, if matrices are my favorite part of GitHub Actions, and they are. I think this is my second favorite part, is being able to see exactly what's going on in a build as it's happening. And so let me just expand that out. Let me actually refresh that. Sometimes it takes just a second to catch up and get the information coming from the runners, especially on larger builds. Refresh that one more time. And there we go. If I expand that out, I can actually see the results of the command that are running. And what you actually start seeing is that we're running an iOS emulator, and it is if you were able to get a console on the machine, you would actually see it going through and pressing those buttons. We get the second best thing. It's actually telling us that it's tapping these buttons and going through. And so this is actually doing that exact brute force through the application to try to understand what's going on. And it's doing that on the Mac and telling us exactly what it's doing out to the console. Okay. So I actually do love watching my watching this go through the different events. Okay. Cool. So that is take a look at sort of how you get started with CI builds, pull request validation builds within GitHub Actions. I think that that's the easiest way to get started with GitHub Actions, and certainly the most value that you can add to your project is just getting that set up and making sure that you have you have that. I think that the next impressive thing about GitHub Actions is its integration within the rest of the GitHub ecosystem, right? We've taken Actions and we've created a product around that. However, I think that the most interesting thing about it isn't the CI/CD, it's actually the way that it integrates with everything else. Let me give you a more concrete example, and that is, sorry, let me close that. And that is some of the tools like Dependabot. If you have projects on GitHub, you may have noticed this before. We have some security validation that we can perform. So the nice thing about GitHub is that we have a lot of code, right? People put their open source projects on GitHub, and what we're able to do with that corpus of information is start to analyze it and start to understand how people are writing code that might be problematic. In particular, we can understand the code that you are building and the code that you're ultimately relying upon. And we can compare the dependencies that you use in your project to a database of known vulnerabilities in software. So again, this is a Node application. If you're familiar with Node, you'll know that the package JSON defines dependencies. In this case, I depend on a tool called Express. That's a web framework, and I'm using version 4.16.4. I've also got some dev dependencies. I've got test frameworks that I use. The reason that they're called dev dependencies is that I don't actually deploy these as part of my application. I just use them in development. So this is my things that I need for just building and testing. But Express is a proper dependency. I actually need that. That's what listens for HTTP calls. So very, very important. And I wish I could say that I had set this up. In fact, this was just a natural part of the development process, and I decided to save off the repository before I was working in a repository called Calculator. This is calculator.bad. The reason it's calculator.bad is you can see this yellow bar right here. We found a potential security vulnerability in one of your dependencies. Wow, that's shocking, right? And now this is, like I said before, this is an open source project, but nobody else can actually see this for safety, for your safety. We'll only show this to you as the administrator, the owner of your repositories. But I do get to see it, and so I get to click in, and it will tell me what has happened. And well, okay, so there's this package called LowDash, and it has a critical severity security vulnerability. And why should I care about that? I'm not using LowDash. It wasn't in my dev dependencies. It wasn't in my dependencies. The only thing that I was using was actually Express. Well, it turns out that Express depends on LowDash. So this is what's called a transient dependency. It's not something I depend on directly, but it's something that one of my dependencies depends on. And so GitHub has analyzed not just the packages that I use directly, but the packages that those packages use. And it's able to identify when one of those has a security vulnerability. And this is supremely important. I realize this is NDC Oslo, but listening to me, you might be able to tell that I'm an American. One of the largest security breaches for financial information was because of an outdated dependency. An attacker was able to get a foothold on a public-facing website for a credit bureau. And once they were in the website, they were able to just keep going through the network and ultimately landed on a database of about half of America's, literally, millions and millions of people, their credit information, and get their social security numbers, their credit information, and ultimately, potentially, commit identity fraud against these people and sign up for credit in their name, all because of an outdated dependency on a publicly facing just a marketing website. That's how it started. So these sorts of things are critically important. And so GitHub is able to tell you when you have an outdated dependency. The cooler thing is that the tool telling you that you have an outdated dependency is a tool called Dependabot, and it is a bot. The nice thing about robots is that they can help make our lives easier and do some of our work for us. And in fact, Dependabot has not just told us that we have a problem. It's actually, you can see here, opened a pull request. It, if we click in, has updated our package JSON, moving us from LowDash 4.17.11, the vulnerable version, to 4.17.15. So it knows that we've got a security vulnerability, and it knows the next version that fixes it. And it knows semantic versioning, it knows these rules, and it can suggest a fix for us. And it will open a pull request with that fix. That is super cool. The best part, though, is that since we have GitHub Actions on this repository, we will take the pull request that Dependabot opens with this upgrade, and we will run our test matrix against it. So Dependabot opens a pull request with this new version, and we will run all our build and all our tests against it. And so we know that there was no problem with addition here, and we'll know that across the matrix. In this case, node 8, node 10, and node 12, and we'll have high confidence that Dependabot, its change, is going to be fine. And so I could just go ahead and click merge pull request. I could take this a step further, and I could even set up a GitHub action to when the author of the pull request is Dependabot, that I could go ahead and auto merge its changes if my builds and test passes. Now, obviously, you have to have a high degree of confidence in your tests in order to do something like that, but I think that's some next level stuff. You get security updates automatically merged into your main branch without even having to do any work on your own. As it stands, now I get security updates, pull requests, and all I have to do is click one button here with a high degree of confidence. So I think that's a good first step. And so that's the sort of integration within the GitHub ecosystem that I'm really excited about. Anthony, I just saw your question. Let's see. The question was, there we go. Does Dependabot support .NET Core and .NET Framework? I will find out. I don't remember all of the all of the ecosystems and all of the platforms that Dependabot supports. I will find out and I will get back to you. I will follow up in Slack in the conference room 4 channel as soon as we're done here. Cool. So I want to go back to one thing that I sort of alighted over early in the talk. The name of this product is GitHub Actions. And I've talked a lot about workflows. We've built out a workflow for a .NET application. We've built out a workflow that builds and tests our Node.js application, and one that builds out a Swift application, an iOS app. And you can see that the name of this folder here is workflows. This is where our workflows live. I've also mentioned that, kind of in passing, that we have the notion of actions within workflows. So let's actually define what this is and what's going on here. So we've got these run steps, and that's generally how we will do our build and run our tests. I mentioned that that's just how, how you can run commands. This is basically just running shell commands, exactly like you would do within your project. But ahead of those, we've got things like this step right here that checks out our Git repository so that it can actually do that build and test. And instead of the run command, we've got this uses command, and we're using actions checkout v2. So what we're doing here is we're invoking an action. And this is really where GitHub Actions gets its name from. And so nomenclature-wise, workflows are running your builds, running your triggers whenever you open a pull request, have an issue comment, that sort of thing. And an action is something that you can run as part of that workflow. And it's a reusable piece that can be used by multiple workflows. So you can create an action yourself, either to be used by multiple repositories that you have, or you can share it and multiple people can use it. And so the best place to find these actions is the GitHub Actions Marketplace. Here we go. And so this is basically program components that you can use within your actions to make things easier. For example, if you use BuildKite, if you're a BuildKite user, BuildKite themselves have built an action to allow you to create a workflow to more easily interact with BuildKite, or with CodeClimate, or with coveralls. And so there's actually a community of actions that you can use to level up your workflows. So instead of trying to figure out how to invoke coveralls to do your code coverage, instead of trying to figure out how to interact with Axosoft Glow, this is GitKraken Glow, which is a sort of Kanban board that over top of GitHub Actions. It's a really cool piece of technology, and you can build an action that will move your Kanban cards around from one state to another. And you can imagine when somebody adds an issue, or when somebody closes an issue, that this would be a really cool way to interact. So you can actually click into here and understand exactly how you need to get started with this action in your repository. So there's an example there. Or I can click into this and see how to work with my GitKraken Glow board. There's an example there. And that's just some YAML that you could copy and paste. Now, again, one of the things that we've tried to do with GitHub Actions is make this as easy as we can. And so, in fact, when I'm in the editor, again, I mentioned that we have syntax highlighting. So I know if I've got a typo, I get red squigglies. We've got suggestions, so I might know how to limit this scope. But we've also got, right here, a link into that marketplace. So if I wanted to do coveralls code coverage, I can get all that information right here from within the editor. Now, again, a lot of people, a lot of organizations have built out actions that you can reuse within your workflows. We're really, really happy to see that. But the thing that I think is cool is that it's really easy to build out your own actions. And if I go to github.com/actions, why don't I do this in incognito so that I don't need to log in? If I go to github.com/actions, I can go to the toolkit, and this will actually tell me, give me basically a way to bootstrap a new action. It's actually really simple to build an action, and I can use this toolkit to do that. So this is a set of JavaScript libraries that will let me parse the reason that I'm being invoked as an action. Again, we have those triggers, like you can run on pull request, you can run on push. This will give me the ability to inspect the reason the workflow is running, and it'll give me the ability to call back into GitHub directly. So I can talk to the GitHub REST API. It's a tool called OctoKit. And so I can use OctoKit to update things within the repository that I'm being called from. So it's what allows me to do that automation that we talked about in the beginning of the session. So I know when an issue comes in, and I can react to it. So there's also a starter JavaScript action and a TypeScript action that you can get started with. And these are templates. So you can actually just click one button and get started. And so with an action, you can actually do a number of interesting things. Let me go back to one of my repositories. I hope that you've played Untitled Goose Game. I actually don't play a lot of video games. However, I am really taken with Untitled Goose Game. If you haven't played it, you play. I'll just quickly Google it. You play a goose. You play an angry goose, and you go through and you look nice and cute and innocent, but in fact, your goal in life is to terrorize these friendly townspeople. You sneak up behind them, you quack at them, chase them around. That is actually the point of the game, is to terrorize these poor townspeople. All they want to do is play soccer, and you're keeping the soccer ball away from them. Now, if you are like one of my coworkers, you might be inspired by this. And you might create a GitHub action that works on issue comments. So here I have an issue, and if I were to comment on it, I have a workflow that runs every time an issue comment is created. In fact, it's running right now. And if we click over to actions, we can see exactly what it's doing. There we go, click on that. See what the workflow is doing. This is the honk workflow, and it's running my friend Jeff's action. There we go, it's run that. Oh, and if you'll notice up here in our tabs, I've got the number 1 prefix. So this action's actually done something to that issue. And if I come back, and hit reload, my issue comment's gone, and it's been replaced with this honk, this angry goose. So let's take a look at this action. Now, one of the cool things about GitHub Actions is you can actually identify an action, because the way that this action is named, kind of, if you're familiar with GitHub, this looks like the user/repository notation, and in fact it is. So GitHub Actions, an action itself, is run out of a repository. So I can go to github.com, Jeff Rafter / honk-action. There we go. So this is the action that we just ran. we can actually open up honk.ts, that's the TypeScript, and we can see exactly what this action has done. So again, we have the ability to get to OctoKit. That's how our actions can interact with GitHub. We will also be delivered the context, the GitHub context, which is the information about the workflow run and the actions run that is occurring. One of those things that we'll get, since we're running on issue comment, is the issue comment body. And what we'll do is I examine the comment body and see if it matches honk. If you're familiar with regex, you'll know that this is looking for the word honk case sensitively. So if we find honk in the comment body, we'll return. Otherwise, we'll delete the comment that was presented and we'll create a new comment with a picture of an angry goose. So knowing that, if I write the comment honk and add that comment, now that will stick around. And if I click on another actions run, once this finishes, we should see that our issue comment in fact stayed. Now, this is, I concede, a totally ridiculous example. Obviously, you would never do this, except maybe, does April Fool's Day exist in Oslo? If so, this is the sort of thing that you might terrorize your coworkers with. There we go. And if I click reload, in fact, my honk comment stayed. So we do know the trick. So again, totally ridiculous, not the sort of thing that you would ever do, but it does show you that the spirit of GitHub Actions, which is automating things within your repository, even if that thing is totally ridiculous, like deleting comments and adding an angry honking goose, is there. So you can use GitHub Actions for your CI/CD workflows. You can use GitHub Actions to automate things within your repository using actions that have been created by the community. So moving GitHub glow cards or doing code coverage, interacting with your code coverage utilities. Or you can build your own actions, even if that thing is terrorizing your coworkers. Hopefully, you'll come up with more productive things like automatically triaging issues. And that is, in fact, something that we do quite often at GitHub, is using actions to triage issues. But, you know, hey, if you're an angry goose in your heart, then I don't want to be the one to stop you. We are out of time. However, I will happily take questions. I'll be in Slack, and I'm happy to take questions there in the Conference Room 4 channel. Of course, you can also get in touch with me. Feel free to, let's see. Sorry, I was trying to find the slide with my contact information. There we go. Feel free to get in touch with me. Actually, the best way to reach me is on Twitter. I'm at eThomson. That's ETHOMSON. Feel free to reach out, and I'm happy to answer your questions, whether it's on GitHub in general or GitHub Actions in particular. And thank you so much for coming to virtual NDC Oslo.